Welcome back everyone. In this video we're going to talk about binomial random variable. So before we get into binomial, let's assume that we have sequences of Bernoulli trials. And as you know, each Bernoulli trial has two outcomes, success and failure. And when you have sequences of them, that means you have a sequence of experiments, and each experiment has two outcomes of success or failure. And there is something special about this sequence of Bernoulli trials. There are independent and identically distributed Bernoulli trials. What do they mean, independent and identically distributed Bernoulli trials? Well, independent means the outcome of one Bernoulli trial does not influence the outcome of another trial. And identically distributed means each trial is described by the same probability of success. So probability of success between these trials do not change, stays the same. P, or probability of success, stays the same. So if we have such a sequence of Bernoulli trials, we can introduce a new random variable, and that is a binomial random variable. Binomial random variable notation is n sub n, and what it represents is number of successes in n trials. So suppose we have those n sequences of Bernoulli trials, and among all those trials, you will have so many successes and so many failures. So n sub n represents the number of successes in those trials. And n sub n is a binomial random variable having n trials and probability of success p. So here you see that binomial random variable has two parameters, n and p. We define binomial random variable this way. N sub n follows binomial with two parameters, n and p. So let's look at some examples of binomial random variable in different applications. First, flipping a coin 10 times, and x is number of heads obtained. What is the p? Well, we know that this random variable is 10 Bernoulli trials. So n is 10. But what is the p? Probability of success here. And success is number of heads obtained. And success is obtaining a head. So p is 0.5, right? 50%. Therefore, the random variable that we have here is n10, right? Number of successes in 10 tosses of coin. It's a binomial with two parameters of 10 and 0.5. And that's how you define the random variable. A worn tool produces 1% defective parts. X is number of defective parts in the next 25 parts produced. So here we have 25 trials. So that's your n, number of trials. What is the probability of success here? And here, note that success, or quote-unquote success, is when a part is defective. And probability of that is 1%. So the random variable is n25, which is a binomial random variable, 25, and probability of success 1%. A multiple choice test contains 10 questions, each with 4 choices, and you guess. Basically, you have no idea about this test. You come to the test unprepared, and you have 10 questions in front of you. The number of correct answers at the end of the test is a binomial random variable, because on every trial, which is every question, there's a success and there's a failure. Probability of success is 1/4, right, or 25%. And the random variable of this experiment is n10. 10 questions, that follows a binomial with n equals to 10 and P equals to 25%. Of the next 20 births, let X be the number of females. Well, you have 20 trials, independent and identically distributed trials. And assuming that we have only males and females for a newly born child, probability of being a female can be safely assumed is 50%. So the random variable of this experiment is n20, which follows binomial of 20 and 0.5. That's the number of females in the next 20 births. So some of the key characteristics that you can realize in all of these examples is that we have a fixed number of trials. Each trial is termed as a success or failure, and X is the number of successes. Probability of success in each trial is constant. It doesn't change. So we've got the same P for each trial. And the outcome of successive trials are independent. As long as these four conditions hold, we have a binomial random variable. Before we get into the PMF and expected value and variance of binomial, I want to introduce you to binomial coefficient. And binomial coefficient is a big part of calculating probabilities associated with binomial random variable. So what you see here is the binomial coefficient, and the way that you read this is n choose x. And n choose x is the number of different ways you can choose x items from n items, right? For example, if you have a bowl full of different marbles, and you have 10 marbles in there, and you want to know how many different ways exist to select 2 marbles out of this 10, you basically calculate 10 choose 2. And how many different ways really exist is 10 factorial divided by 2 factorial times 8 factorial, right? Following this formula. And what is that equal to? Well, you can cancel out 8 factorial and 10 factorial, and what you would be left with in the numerator would be 9 times 10. So that is equal to 90 divided by 2 factorial, which is 2, so 45. So there are 45 different ways exist to select 2 items out of 10 items. So given that, let's look at the PMF and CDF of binomial random variable. So here, first, what is the range of a binomial random variable? Well, let's go back. Binomial random variable is the number of successes in n trials. In n trials, how many successes you can get? Possibly. You can have 0 successes, 1 success, all the way to n successes. So therefore, the range of binomial is from 0 to n. What's the PMF of binomial random variable? Essentially, the formula that you can calculate probabilities for binomial is here. And this piece here is binomial coefficient. And the CDF is probability of x less than or equal to x. That's a summation over PMF from 0 to x. So this x is this one. Let's say that you have a bowl full of marbles, and there are 10 marbles in there. Out of those 10, 4 of them are gold marbles, okay? And you're selecting marbles out of this bowl randomly. So probability of grabbing a gold marble is 4 out of 10, 40%. But you want to try this experiment 10 times. You want to select marbles randomly out of this bowl, and You want to know out of 10 times, what's the probability that 2 of those 10 times you would end up selecting a gold marble, okay? Essentially, you want to calculate probability of n10, right? Number of successes in 10 trials equals 2. 2 successes out of 10. What is that probability? Well, you got to follow this formula. It's going to be 10 choose 2, right? So here n is 10, x is 2, times probability of success, p. Probability of success here is there are 4 gold marbles in the vase out of 10. So probability of success is 40% chance that you grab a gold marble, to 2 times probability of failure, 1 minus p, 60% chance that you grab a non-gold marble, to the power of n minus x. In this case, 10 minus 2, so 8. So when you calculate that, that's the probability of 2 successes out of 10 trials. The answer is about 0.12. So that's a quick example of showing you how to use this formula to calculate probabilities. So now let's take a look at expected value of binomial random variable. Expected value can be calculated with n times p. And standard deviation is also here, square root of n times p times 1 minus p. As you can see, in all of these formulas are functions of n and p. As long as you know n and p, you can calculate everything with respect to binomial random variable. And here are examples of different binomial random variables. For example, here, n is 20 and p is 0.5. So you have 20 trials, and probability of success is 50%. So your random variable essentially is n20, and it represents the number of successes out of 20. The highest probability is associated with 10 successes, right? 10 successes have the highest probability. But number of successes ranges between 0 to 20 with different probabilities. Obviously, the highest probability is associated with 10 successes, which is the expected value of this random variable. And here in this graph, you can look at 2 more random variables that are listed here. In the next video, we're going to look at a couple examples on binomial random variable.